Right, okay, so I'm going to work through some examples of genetic cross diagrams, okay, and show you sort of how you might be asked to complete those crosses. So we've got an example here. Now, the disease itself, you don't have to have heard of. Okay, this might be something that you've never come across before, but ultimately it doesn't matter because the information that you need to answer the question is given within the letters. Okay, so you need to look for, again, things that are hiding in plain sight. Okay, so you've got Marfan syndrome. I've never taught you about that. Okay, we don't need to know what it is, but we can still do the question. It's a rare genetic disorder that causes problems with many body systems, and it's caused by a dominant allele. Okay, so we know that Marfan syndrome is dominant, and they've given us the letter to use. So they've given us a capital R. The normal allele is recessive with a small r. Okay, so that is exactly the same as all the Punnett square, all the genetic cross diagrams that we've done. Okay, now this is where you might get caught out. Okay, because they're expecting or assuming that you understand what this word means. Heterozygous. Okay, because the man is heterozygous for Marfan syndrome. Okay, so if he is heterozygous, that means he has different letters. So the man must have one of each. He must have a big R and a small r, because heterozygous means different letters. Okay, and he has a child with a woman who does not have the disorder. Okay, so if she doesn't have it, she must have two recessive alleles. Okay, because if she had a capital R, then she would have this syndrome. So the woman must be small r. Okay, now that we've identified that information from here, the cross is exactly the same as what you've done in the past. Okay, so you would draw out your square, you would put your single letters for the man across the top, you put your single letters for the woman across down the side, and then you do your crosses. Okay, so in this case, because there's a capital R there, both of those two would have the disease. Okay, they would have this syndrome. In this case, if they're both recessive, they don't have it. So I'm going to do this so that I can work out my probability. So here, the ones that do have it, there's 2, and the ones that don't have it, there's 2. So you can write your probabilities in different ways. Okay, you can write it 1-to-1, you can write it, there's a half chance, you can write it 50% chance. Okay, but basically half of those, the probability of is 50% will have it, 50% won't. Okay, so I've got another example here. So this time it's a different disorder. So this is Huntington's disease. Again, it's not necessarily one that you've learned about, okay, but we can still do the question because it's an inherited disorder that affects the nervous system. And again, it's caused by a dominant allele. A man is heterozygous for Huntington's disease, so he's got different letters. Okay, so we know that heterozygous means that he must have one of each. His partner is healthy and does not have the allele that causes Huntington's disease. Okay, so what we need to figure out is, in a long-winded way, exactly what we've just done for the other question. So what are the genotypes? When it's the genotypes, it's the letters. Okay, so it's asking you what letters do these two people have, and they've asked us, they've given us the letters they want us to use. So you've got a capital H, which again reminds you that it's dominant. So capital H for Huntington's disease, small h for healthy. Okay, if the man is heterozygous, he must have one of each. If the woman is she doesn't have the disease, then she must have 2 small h's, because if she had a big H at all, then she would have that disease. Okay, so because it's a recessive allele, because the recessive one is normal, she must have 2 of those genes. Right, so that again, you're then doing the cross. So they want to have a child. So use a Punnett square to determine the probability. Now please remember this probability, because that's usually the last bit that people forget to do, okay? And it's a 4-mark question. One of those marks will be for the probability. Okay, so I'm going to draw my Punnett square. I'm going to put my letters, remember that around the side it's always the singles. I'm going to do my cross, so big H, small h, big H, small h, small h, small h, small h, small h. Okay, so do have equals, don't have equals, so it's going to be 2 have it because you've got the single alleles here, and 2 of them don't have it. So again, it's a 50% probability, a half probability, okay? But don't forget that that is one of the marks, so you must always write what the probability is, okay?